The experiment setup involves two bowls positioned adjacent to each other. One bowl is filled with warm water, clearly identified with a label. The second bowl contains cold water, also marked with a distinct label. This setup is designed to demonstrate temperature differences and their effects. The visual contrast between the labeled warm and cold water bowls is key. The experiment will likely explore principles related to heat transfer or convection. The water is contained within a bowl. The water's temperature is elevated above room temperature. Subtle steam rises, visually indicating the warmth of the water. The steam is a result of water molecules transitioning into a gaseous state due to heat. The scene focuses on a bowl filled with cold water. The water's low temperature causes condensation to form. Condensation is visible on the exterior of the bowl. This phenomenon indicates the water's coolness relative to the ambient air. The presence of condensation serves as a visual cue for the water's temperature. A spoon is a utensil consisting of a small, shallow bowl. The bowl is oval or round. A handle extends from the bowl. Spoons are commonly made of metal, plastic, wood, or porcelain. They are primarily used for eating liquid or semi-liquid foods. A spoon is placed into a bowl of warm water. The metal of the spoon begins to heat up. This heating demonstrates thermal conduction. Heat energy transfers from the water to the spoon. The spoon's surface comes into direct contact with the warm water. This contact facilitates heat transfer between the water and the spoon. Heat energy flows from the warmer water to the cooler spoon. This process continues until thermal equilibrium is reached. A spoon is submerged in warm water, reaching thermal equilibrium. The spoon is carefully lifted from the warm water. Surface tension causes water droplets to adhere to the spoon. These droplets reflect the ambient light, appearing as small, glistening spheres. The water's warmth contrasts with the cooler air, initiating a slight evaporative cooling effect on the spoon's surface. A spoon is held stationary in the air. This pause allows residual water to gather at the spoon's lower edge. Surface tension causes the water to form droplets. Eventually, gravity overcomes the surface tension, and the water drips off. A spoon, initially at room temperature, is placed into a bowl of cold water. The cold water acts as a thermal sink, drawing heat away from the warmer spoon. Heat energy transfers from the spoon to the water due to the temperature difference. As heat transfers, the metal of the spoon begins to cool down. This process continues until thermal equilibrium is reached between the spoon and the water. The spoon's surface acts as a thermal conductor when it touches cold water. Heat transfers from the spoon to the water due to the temperature difference. This heat transfer results in the cooling of the spoon. The process continues until thermal equilibrium is reached between the spoon and the water. The scene visually represents a spoon undergoing a temperature change. The spoon transitions from a warm state to a cold state. This transition highlights the contrast in temperature. The change in temperature is the focal point of the scene. The initial warmth sensation arises from the physical contact between two substances of differing temperatures. In this case, it is the spoon and the warm water. The spoon, initially at a lower temperature, experiences a rapid increase in temperature. This temperature change is due to the transfer of thermal energy from the warmer water to the cooler spoon. This transfer of energy is perceived as warmth. The intensity of the warmth is related to the temperature difference and the thermal conductivity of the spoon. The sensation of initial coldness arises from a rapid temperature change on the skin. This change is detected by thermoreceptors, specialized nerve endings sensitive to temperature. When a cold object makes contact, these receptors send signals to the brain. The brain interprets these signals as a distinct feeling of coldness. The sensation involves perceiving temperature changes as an object moves between different thermal environments. This is exemplified by a spoon transitioning between bowls of varying temperatures. As the spoon moves from a warmer bowl, it initially feels warmer to the touch. Conversely, moving the spoon to a cooler bowl causes a sensation of decreasing temperature. This sensory experience highlights the human body's ability to detect relative temperature differences. Heat transfer is the process of thermal energy exchange due to a temperature difference. In this scenario, heat energy moves from the warm water, a region of higher temperature, to the spoon, which is initially at a lower temperature. This transfer occurs via conduction, where energy is passed through direct contact. The animated particles visualize the movement of this thermal energy. Cold transfer occurs when heat energy moves from a warmer object to a colder substance. In this case, heat energy transfers from the spoon to the cold water. This transfer continues until thermal equilibrium is reached. The water gains energy, increasing its temperature, while the spoon loses energy, decreasing in temperature. Warmth is defined as having a moderate level of heat. It indicates a temperature that is neither hot nor cold. Warmth is a subjective perception of heat. It is generally considered a comfortable temperature. The term warm is relative and depends on the context. Cold is defined as having a low degree of heat. It signifies the relative absence of warmth. The term cold describes a state where thermal energy is reduced. This reduction in thermal energy results in a lower temperature. Therefore, cold is fundamentally the opposite of hot or warm. It is a subjective perception of temperature relative to a reference point. Water exists in different states depending on its temperature. The temperature range for water spans from freezing to boiling points. At the freezing point, water transitions into a solid state, forming ice. As temperature increases, ice melts and water exists in its liquid state. Upon reaching the boiling point, water transforms into a gaseous state, becoming steam. This temperature range is critical for various natural processes and human applications. Water molecules are in constant random motion. This motion is due to the kinetic energy of the molecules. Temperature is a measure of the average kinetic energy of the molecules. In warm water, molecules have higher kinetic energy. Therefore, water molecules move more rapidly in warm water compared to cold water. Water molecules are in constant random motion. This motion is due to the kinetic energy of the molecules. In cold water, molecules have lower kinetic energy. Lower kinetic energy results in slower molecular motion. Therefore, water molecules move more slowly in cold water compared to warm water. The spoon is made of metal. Metal is a good conductor of heat. This means heat transfers easily through the spoon. The spoon quickly heats up or cools down. This property affects how the spoon feels to the touch. Heat conduction is the transfer of thermal energy through a substance from a region of higher temperature to a region of lower temperature. In a metal spoon, heat is conducted from the hot end, for example, in hot liquid, to the cooler end held by a person. This heat transfer occurs through the vibration and collision of atoms within the metal. Metals are excellent conductors of heat due to the presence of free electrons that can easily transport thermal energy. As heat is conducted, the temperature of the entire spoon gradually increases until thermal equilibrium is reached, or the heat source is removed. Temperature is measured using a thermometer. A thermometer indicates the degree of hotness or coldness of a substance. The thermometer can accurately measure the temperature of both warm and cold water. The reading on the thermometer corresponds to the thermal energy level of the water. Temperature is a physical quantity expressing hot and cold. Different scales have been developed to measure temperature. Celsius is a temperature scale where 0 degrees Celsius is the freezing point of water and 100 degrees Celsius is the boiling point. Fahrenheit is a temperature scale where 32 degrees Fahrenheit is the freezing point of water and 212 degrees Fahrenheit is the boiling point. The Kelvin scale is an absolute thermodynamic temperature scale where 0 K is absolute zero. Conversion formulas exist to convert between Celsius, Fahrenheit, and Kelvin. Water temperature significantly affects aquatic life and ecosystems. Temperature influences the metabolic rates and physiological processes of aquatic organisms. It also affects the solubility of gases, such as oxygen, which is crucial for aquatic respiration. In industrial processes, water temperature impacts reaction rates and the efficiency of cooling systems. Maintaining optimal water temperature is essential for both environmental health and industrial performance. Warm objects are common in our daily experiences. A cup of tea is a typical example of a warm object. The warmth of tea is due to its higher temperature compared to the surroundings. Other examples include freshly baked goods. Heated blankets also provide warmth. These objects transfer heat to their environment, including our hands or bodies. Cold refers to the absence of heat or a relatively low temperature. Ice cubes are a common example of cold objects in daily life. They maintain a temperature at or below the freezing point of water. Refrigerators are designed to keep food cold, slowing bacterial growth. Metal objects left outside in winter can also feel extremely cold. The sensation of cold is the result of heat transferring away from the body. Hot water poses a burn risk and should be handled carefully. Always test the water temperature before use to avoid scalding. Supervise children closely when they are near hot water sources. Install anti-scald devices on faucets and shower heads. Be mindful of hot water pipes and surfaces that can cause burns. In case of a burn, immediately cool the affected area with cold water. This is a side-by-side visual comparison of warm and cold water samples. The comparison aims to highlight the distinct differences between the two water temperatures. Differences in appearance or behavior may be subtle but significant. Temperature affects properties such as density and viscosity. These properties influence how the water behaves under different conditions. The visual comparison provides a direct observation of these temperature-related variations. Temperature significantly influences the density of water. As water temperature increases, its density generally decreases. This is because warmer water molecules move faster and spread out more. However, water's density peaks at around 4 degrees Celsius. Below this, it becomes less dense as it cools towards freezing. Ice floats on water due to its lower density compared to liquid water. Water molecules in ice form a crystalline structure with more space than in liquid form. This expanded structure makes ice less dense, causing it to displace its weight in water and float. The phenomenon of ice floating is crucial for aquatic life, preventing bodies of water from freezing solid. Temperature is a key driver of the water cycle. Increased temperature leads to higher rates of evaporation. Evaporation transforms liquid water into water vapor. Warmer air can hold more moisture, influencing humidity. Temperature gradients drive atmospheric circulation patterns. These patterns affect precipitation distribution globally. Evaporation is a phase transition where a liquid changes into a gas. This process occurs when the liquid's molecules gain enough kinetic energy to overcome intermolecular forces. As temperature increases, the rate of evaporation also increases. Warm water provides more energy to the water molecules. The energized molecules escape from the liquid's surface into the air as vapor. This results in a decrease in the amount of liquid water over time. Condensation is the process where water vapor changes into liquid water. This phase change occurs when the air is saturated with water vapor. Saturation typically happens when air is cooled to its dew point. Cool surfaces, like a cold water bowl, facilitate condensation. Water vapor in the air near the bowl loses energy and condenses into liquid droplets. Heat is a form of energy transfer that occurs due to temperature differences. The sun is a primary source of heat energy for the Earth, providing light and warmth. Stoves are a common artificial heat source used for cooking and heating. Various other sources like friction, chemical reactions, and electricity can also generate heat. Cooling methods involve techniques for reducing temperature. Refrigeration is a common cooling method. Refrigeration systems use a refrigerant to absorb heat. The refrigerant cycles through evaporation and condensation. Evaporation absorbs heat from the surrounding environment. Condensation releases heat to the outside environment. Temperature regulation is the ability of an organism to maintain its body temperature within certain boundaries. This process ensures optimal conditions for metabolic processes and cellular functions. Organisms achieve this through various physiological and behavioral mechanisms. These mechanisms help balance heat gain and heat loss, maintaining a stable internal environment. Effective temperature regulation is crucial for survival in diverse environmental conditions. Warm-blooded animals, or endotherms, maintain a stable internal body temperature. This internal temperature is regulated independently of the external environment. Cold-blooded animals, or ectotherms, rely on external sources to regulate their body temperature. Their internal temperature fluctuates with the temperature of their surroundings. Examples of warm-blooded animals include mammals and birds, while reptiles and amphibians are cold-blooded. Temperature is a critical factor influencing weather patterns. Differences in temperature create pressure gradients in the atmosphere. These pressure differences drive wind, moving air from high to low pressure areas. Temperature also affects humidity and precipitation. Warmer air can hold more moisture, leading to increased potential for rainfall. Global warming refers to the long-term increase in Earth's average surface temperature. This warming trend is primarily driven by human activities, especially the emission of greenhouse gases. Increased greenhouse gas concentrations trap more heat within the Earth's atmosphere. As a result, average temperatures are rising worldwide, impacting various regions differently. These temperature changes contribute to altered weather patterns, melting ice, and rising sea levels. Heat waves are prolonged periods of excessively hot weather. They typically last for several days or even weeks. Heat waves can significantly impact human health, leading to heat stroke and dehydration. Vulnerable populations, such as the elderly and those with chronic conditions, are at higher risk. Staying hydrated and seeking cooler environments are crucial for mitigating the health effects of heat waves. Frostbite is tissue damage caused by exposure to extreme cold, leading to freezing. It commonly affects extremities like fingers, toes, nose, and ears. Prevention involves wearing insulated clothing, staying dry, and avoiding prolonged exposure to cold. Recognizing early signs like numbness and pale skin is crucial for prompt treatment and preventing severe damage. Hypothermia is a dangerous condition that occurs when the body loses heat faster than it can produce it. This leads to a dangerously low body temperature, typically below 95 degrees Fahrenheit, 35 degrees Celsius. Common causes include prolonged exposure to cold weather, immersion in cold water, and inadequate clothing. Symptoms range from shivering and confusion to drowsiness and loss of consciousness. Prevention involves wearing appropriate layers of clothing, staying dry, and seeking shelter from the cold. Consuming warm fluids and avoiding alcohol and caffeine can also help maintain body temperature. Temperature scales are standardized systems for measuring and quantifying temperature. The Celsius scale is based on the freezing 0 degrees Celsius and boiling 100 degrees Celsius points of water. The Fahrenheit scale defines the freezing point of water as 32 degrees Fahrenheit and the boiling point as 212 degrees Fahrenheit. The Kelvin scale is an absolute thermodynamic temperature scale where 0K is absolute zero. Absolute zero is the point at which all molecular motion ceases. Kelvin is often used in scientific applications due to its direct relationship to energy. Temperature measurement is essential in various industrial processes for quality control. It plays a crucial role in maintaining optimal conditions in HVAC systems for comfort and energy efficiency. In the medical field, accurate temperature readings are vital for diagnosing and monitoring patient health. Environmental monitoring relies on temperature sensors to track climate changes and weather patterns. Food safety depends on precise temperature control during storage and transportation to prevent spoilage. Scientific research utilizes temperature measurement for experiments and data analysis across disciplines. Digital thermometers use electronic sensors to measure temperature. These sensors, often thermistors or thermocouples, exhibit a change in electrical properties with temperature variations. The sensor's electrical signal is then processed by a microchip within the thermometer. This microchip converts the electrical signal into a digital reading. The digital reading is displayed on an LCD screen, providing a clear temperature value. The accuracy of the reading depends on the calibration and sensitivity of the sensor and the processing microchip. Infrared thermometers measure temperature by detecting thermal radiation. All objects emit infrared radiation, a form of electromagnetic radiation. The intensity of this radiation is directly proportional to the object's temperature. The thermometer focuses the infrared radiation onto a detector called a thermopile. The thermopile converts the radiation into an electrical signal. This signal is then processed and displayed as a temperature reading. Accurate temperature measurement is crucial in scientific experiments for reliable results. Precise temperature readings ensure the validity and reproducibility of experimental data. Inaccurate measurements can lead to flawed conclusions and misinterpretations of scientific phenomena. Therefore, calibrated instruments and careful techniques are essential for temperature measurement. The experiment explores the fundamental differences between hot and cold temperatures. Heat is associated with the increased kinetic energy of molecules within a substance. Cold indicates a lower level of molecular kinetic energy and reduced heat. The experiment demonstrates heat transfer principles and temperature-related phenomena.